All right, here's a good question. Again, Dalton's law of partial pressures. So you have a vessel, and internal volume of 11.6 liters. And you've got 2.80 grams of nitrogen. That doesn't do us much good, eh? We'll have to convert that to moles. We got 0.403 grams of hydrogen, 79.9 grams of argon. And then they say the temperature, 25, so that would be 298.15 Kelvin. What is the pressure inside? So they're not changing, so it's not a Boyle, Charles, those kind of things. It'll be your ideal gas law. So PV equals nRT, and then they want pressure. So pressure is equal to nRT over V. But the problem is moles, we got 3 of them. Well, we have grams, but we'll convert those to moles. We have 3 of them. So I have to do this 3 times. Or I could just convert all these to moles and then add up the moles and do the PV equals nRT once. Why don't we do that? That might be a little easier. So moles is equal to mass over molar mass. Moles equals the mass is 2.80 grams. Molar mass of nitrogen is 14.01, but there's 2 of them, so it'll be 2 times 14.01, so it'll be 28.02. Okay, so 28.02 grams per mole. So it's going to give me moles there. Okay, let's do hydrogen. Moles will be the mass, 0.403 grams. Molar mass of hydrogen. Hydrogen is 1.01, and there's 2 of them, so that'll be 2.02. I should write that 2 at that, and 2 at that. So divided by 2.02 grams per mole. Grams cancel. And then argon. So moles are equal to the mass, 79.9 grams over argon. I gotta look that up. 39.95 grams per mole. Grams cancel. Okay, calculator. I'll pause while I do that. Okay, I found out all my moles. So, Dalton's law of partial pressure says that the pressure total is equal to the pressure of nitrogen plus the pressure of hydrogen plus the pressure of argon. Now, if I can determine the moles of each of those, and if they're not asking, they just say what's the pressure inside. So they're not actually asking what's the pressure due to each gas. So what I can do is I can just add up these moles and then put it into my formula. Okay, so if I add those up, let me add them. Plus 0.1995 plus 0.0992. So that comes to 2.29942. Okay, so that's my total number of moles. Now, like I said, if they wanted to know the partial pressure due to nitrogen, then you'd use this number of moles and plug it in right there. And you do that, nitrogen. Then you do hydrogen, then you do argon, and then at the end you would add those 3 pressures. But because they don't need to know the partial pressure for each one, I'm just going to figure it all out at once. So the pressure is equal to the number of moles, 2.29942. That's the total number of moles of gas that I've got, times our universal gas constant, 8.314 kilopascal liter per Kelvin mole times temperature. Where was my temperature? 298.15 Kelvin divided by the volume, which is 11.6 liters. Moles cancel, liters cancel, kelvins cancel. So I'm left with kilopascals, and that's a pressure. Life is good. Okay, so let's take our number of moles there, times 8.314 times 298.15 divided by 11.6. So I'm getting 491.366, etc. kilopascals. Oh, great. They want the answer to be in atmospheres. Okay, so the pressure's 491.366 kilopascals. We can multiply it. There's 101.325 kilopascals in 1.000 atmospheres. So I'll take my 491 and divide that by 101.325. I'm coming up with 4.8494. Do they have that? 4.85. That's what I'm going with right there. All right, hopefully that helps you with that one. That's a good Dalton's Law partial pressure question.